Software testing and quality assurance, or QA, used to be an enormous part of the software engineering process. When I worked at Microsoft back in the 90s on Windows NT, the test team was actually as big as the rest of the engineering team combined. In other words, there were more test developers and test engineers than there were product developers. Over the years, this changed dramatically to the point where many test teams have been dissolved and some products don't have any formal test team at all. So what happened? What led to this change in the way products were developed and tested? Hi, I'm John Miller, the deliberate engineer. I spent 30 years working as a software engineer in big tech and a variety of other companies, including 15 years as a principal engineer. 7 or 8 of those years I actually spent as a test developer and a manager of test developers. So I got to see firsthand what it was like to do QA and some of the differences in the type of development. Today I'm going to tell you some of my stories and experiences as somebody who used to be a tester working in test development and the implications to your career, type of work you do, and so on. I'll also tell you about the transition away from test teams and why this may not be the awful thing that it sounds like on the surface. Finally, I'm going to give you some advice about why I think you shouldn't move into quality assurance or testing as a career, and why you should look at moving to a normal product development role if you're already a test developer today. In the old days, when I first started working on Windows NT in the early 90s, the products were produced as box products. In other words, you would take a bunch of media, whether it's floppy disks or CDs, and put them in a box and mail it out when you were done. The idea of online software patching as it exists today was unknown back then. So really, you only had one shot at getting the product right. This really put a heavy emphasis on doing a great job testing that product and having confidence that the bits you're sending out don't have to go through a full recall. In the box software days, products took years to develop, at least products the size of Windows. For example, a normal product cycle for Windows NT would be anywhere from 3 to 5 years. You would spend a great deal of time making sure that you got it absolutely correct, stabilize it, test the heck out of it, and then you'd finally pay the expense of producing the physical media and shipping it out to customers. To help make sure that the product would be good quality, things were approached much more methodically than they are today. There would be a series of scoping meetings where you would talk about what was going to be in the next version of the product. Then proposals would be put together for that. Once the proposals were ready, people would generate specifications that would describe how the product was going to work, and usually implementation specifications that would say how it was going to be put together down to, for example, the interface level. And then test would take a look at the plans that have been written so far and write test specifications. Based on that, they would write tests that verified the adherence of the code that was being produced to the specifications. If there were any differences, either those would have to be fixed or there would have to be a sort of a change request, and then that would be taken into account in the tests so that the test could verify with so-called 100% accuracy that the code was working as designed. A normal product cycle might look something like this. There would be, say, 3 to 6 months of scoping and initial product design work. This would usually be happening at the tail of the previous version. Then that would lead into a set of proposals for what would be done. The designs would be put together. And that design stage might take 3 to 6 months before you got through the initial design. After you did some more prototyping, you'd put together a final design, and then you would implement the final version of the code that you're going to use. Implementation for a 3-year product cycle might be as short as 3 or 4 months to hit code complete. Once you hit code complete, then there would be a long stabilization period where the code was tested and run under a variety of circumstances, and any bugs that came up were fixed. As well, the tests would be written to verify the internal design, and again, any problems that were found there would also have to be fixed. Ultimately, if it was a large project, you would have a bunch of different teams working together, slightly changing the behavior of things, which meant that you had to take a long time to stabilize. In this 3-year product cycle that I was talking about, there would be a stabilization cycle at the end of it that could last more than a year, where you're constantly retesting the software, verifying that it's doing what you want, finding bugs, fixing those bugs, and then testing it again. When I worked at Microsoft, the product itself was compiled daily, or at worst every couple days. And then that build that was produced would be released to the software testers and the software developers, and they would copy it onto their workstations and actually run tests against it. For some of the builds that were considered stable enough, those would actually become the builds that we were developing the operating system on and developing the tests for it. So we'd be self-hosting. Now, when you see a Windows build and it has a number like 496 or 1521, that means that there's been, for example, 1,520 builds that were generated far enough to produce media and to be downloadable onto test machines. It's just a staggering amount of repetitive work. I mentioned earlier that the test teams were quite large. So for a three-person development team, you might have a three-person test development team and another 2 to 4 manual test executors called test engineers. Over the course of one product cycle for Windows, hundreds of thousands of bugs would be found, filed, and either resolved as this is a reasonable behavior or fixed. Two other important parts of the software validation were stress tests and deployments. A stress test is where you take a relatively simple program and run it in a loop. For example, for memory allocation, it would allocate some memory, free that memory, allocate some memory, free that memory. Just do that in a loop. When you have this running for hundreds of different components or thousands of different components exercising a variety of APIs, it puts a tremendous load on the system. This, in turn, helps you find things like timing issues and bugs in the system. So the stress testing was one of the critical mechanisms that we had for finding problems with the system. Even though the stress tests themselves didn't take very much work to write, they were incredibly productive. The second type of test that we would run is something called a deployment. This is similar to the dog fooding I described earlier, where you'd take the component and you would use it the way you expect a customer to use it. For example, one of the teams that I worked on in the mid to late 90s was IP security, and we would do a deployment of IP security into the Windows NT development group, which was thousands of different machines. These deployments helped us understand whether the system was usable and whether it worked correctly in a real production environment. By the time Windows 2000 shipped in the year, you guessed it, 2000, the Windows team had become a huge engineering organization. There were more than 5,000 test developers and test engineers working on the product. About this time, I got a real reality check. Up until Windows 2000 shipped, I'd always been told by my management that no, a test developer track is every bit as important and every bit as well compensated and every bit as good for your career growth as working as a production developer. It was true. A lot of the test developers in Windows were as competent and as experienced as some of the more junior product developers. However, as I got to know more and more people in the team, one day I had a sit down with one of the people in HR, and she sort of told me the way that it works. We tell people that test is important, but the fact is, if you think of it from a lifeboat principle, which is who would you kick out of the lifeboat if the lifeboat was too full, you're always going to need product developers because you have to have a product to ship. But you can sacrifice some of the test developers if you need to, because the worst that would happen is you'd ship a product that isn't tested quite as well, but you'd still have a product to ship. Between that and seeing the trajectory of some of the more senior test engineers' careers, I realized that no, it would make a lot more sense to be in the part of the job that's actually producing the code that ships. Test development is fun, it was interesting for me, and you could move up very quickly in the ranks of test, in part because there's so much attrition. I moved away from test at that point and went through a variety of different roles. One of the places I wound up was in research, and in research I got to read a lot more than I normally did, and I also got exposed to presentations and to papers that talked about the efficacy of different types of testing. This paper took a look at all the bugs that were filed, and it took a look at the resolution status. In other words, was the bug resolved as won't fix? Was it deferred to fix later and then never really fixed? Is it something that was considered a high priority? It also took a look at the impact of the issues and whether customers or beta testers reported these issues before they were found by the test team. What it said was the most important bugs came from three sources. The first was stress testing, which turned up a lot of cases, especially for overloaded machines, that would actually affect the customer had we not fixed those issues. The second was deployment, which often led to redesign or to refining parts of the product that we were making. The vast majority of the bugs found through other mechanisms, for example, bugs that were found by testers who were checking to make sure that the implementations matched their design against internal components or against the external interfaces. A variety of those wound up being bugs that introduced a great deal of churn to fix, but they didn't actually keep the customers from hitting any problems that they would have. As a test developer myself, this was especially disheartening because what it meant was the vast majority of the time that I'd spent implementing tests actually slowed down the product without giving any appreciable improvement in the experience to customers. I say it slowed down the project because half of the engineering resources were dedicated to producing tests. And then the developers, the product developers, would have to interpret the results of those tests, debug the results, help us to get the tests correct in the cases where there was a disagreement how things would work, possibly have to churn the code, modify their implementation to match the design spec, or spend some of their time updating the design spec. A lot of work went into it. So something that, as I said earlier, took maybe 3 or 4 months of code work for a 3-year product cycle, the testing made that extend by more than a year when it really didn't need to. In 2010, I wound up moving to the Cosmos team, which is part of Bing. It's an implementation of a large distributed store with MapReduce infrastructure on top of it. If that doesn't make any sense to you, you don't really need to know what it does other than to realize that it involved tens of thousands of servers working together to solve problems, and there was a lot of complexity to it. A year or 2 before I came to the Cosmos team, that part of the company had actually dissolved their test teams. The test developers who met the bar were moved over to production development. Those who didn't were encouraged to find work elsewhere or to brush up on their skills. As a result, there was almost no test team for the Cosmos team and for the broader infrastructure as a whole. Whereas before you might have had more test developers than you had production developers, now you just had production developers, and they were responsible for ensuring their code had the correct quality. There was still a small test team, but they worked more on end-to-end stuff and integration rather than any particular component. Changing a company from one way of doing business to another is not necessarily going to be very smooth. So in this case, as the test team was removed and people were converted into developers, the developers had to get used to doing more to ensure the quality of their code. They had to write appropriate unit tests and do appropriate performance analysis to make sure the code was working correctly. Whereas before, this was something that some developers at least didn't have to do at all. 10 years later, after that, so 2020, the team was still operating without a real test team, just the developers making sure their code worked. And they were producing fine results, which tells us that the test team, it may have been adding value, but the value probably wasn't proportional to the resources consumed in doing it. I also spent some time at Amazon as a principal engineer, and it was very much the same story there, at least for the team that I was in. Out of a couple hundred developers, there was a test team of less than 10 people. They typically worked on certifications for builds of the client. The developers who were making the services were expected to make sure they worked correctly. It wasn't just that you tested it and shipped it with high confidence. The way that we deployed the services and updated them and patched them, all of that was intended to be very easy to diagnose and intended to be very easy to roll out a new build and roll it back if there was a problem. So in other words, rather than making sure you had it perfect the first time that you shipped it out, you would ship something that you were pretty confident mostly worked, and if it didn't, well, you'd just roll it back, and the worst thing that would have happened is a couple % of people would have had a little hiccup in whatever they were doing that might have just fixed itself, or if they retried a little later, would work just fine. There's 2 big benefits to this approach of just fixing problems that actually crop up in customer use. The first is that you can produce things incredibly quickly. So producing a new service at Amazon can be done very fast. It can be done in probably a 1/5 or a 1/10 of the time that it would take with a more formal testing effort. The second thing is it's much cheaper to ship out the products like this. So not only is it faster, you pay for a 1/5 of the development resources, but since you have no test team, all the developers you have are actually producing features and code that ships. So it's cheaper, it's faster, and overall, to me, that means that it's better. If you're someone who's working in QA today, it's entirely possible you're working at a company that absolutely relies on quality assurance and values it very highly, rewards it, and has a good career path for it. But should they? Unless you're working in some sort of an embedded environment where you just can't update the software, you're probably better off working with a skeleton test team and instead having a very responsive deployment mechanism that lets you update the code whenever a real problem is found, and something that will let you roll back updates as you send them. Even if you're enjoying your QA job, chances are that it's not something that's going to be easily transferable to other companies. I would still recommend that if you're a coder working in QA, you consider becoming a coder working on the actual production code. That is something that will be valued everywhere, And when a company has to downsize or a particular project needs to reduce its headcount, you're going to be safer than somebody who's working in QA. You will also be able to point at the things that are shipping, and instead of saying, I made that better, you'll be able to say, I made that. And that winds up being quite a valuable thing to do. So that's my story of how I started out working in software test development, and how I went from that to a world where you didn't test things so much. Instead, you shipped them out and you made sure that you would know when they failed and you'd be able to update them quickly. If you have stories of your own from this kind of experience, I'd love to hear about them. Please put them in the comments down below. Or if you don't agree with the things I'm saying, I'd also love to hear about that. We can have a nice discussion. Again, just feel free to put it down below. Thank you for making it this far, and keep on pushing forward. Hi, this is John. Thanks for watching. If you enjoyed this video, please think about subscribing so you get notified of my future videos. Also, if you are interested, you might want to check out the video I have linked here. Thanks, and keep on pushing forward.